Hello and welcome to this short session on the Aquatic Informatics time series rating review tool. My name is Tom. I'm a solutions engineer at Aquatic Informatics, and it's my pleasure to host your session today. Here is the rating tool main screen. There's a lot going on here. We're going to look at some of these things, and we're going to go into the background of how this was developed and ways that you can use the rating review tool to create rating curves. So this example here shows you actual rating curves made by me, not a hydrologics expert, but just for the purposes of demonstration, from real data, however, real field visit and stage data. We're going to dig into that and some of the tools and reasoning behind it. On the left, you see some of the field visits that are available, or all the field visits that are available for this particular location. We can turn them on or off, the ones that we're using and the ones that we're not using, on the screen at any time. We have three rating curves here for three different time periods, rating curve 1, 2, and 3 to cover different times. And we'll get into that as well. You see the actual field measurements that are being used in creating and analyzing the curve. Here we have the rating periods for the different rating curves that are there. In this example, we're using a blend to go between rating curve 1 and 2. This is something that's used in the South Pacific, where this example comes from, whereas in North America, you might not see this. You might see something that is only done using shifts, but the tool supports all that. We see data grades for the data here, and you can see the data grades on the bottom of this bar to show you what the grade of the finished output might be, and we'll talk about that as well. We have a calibration box here, and we have some error stats to help us developing our tool. There's other things we can do here as well, and we'll talk about some of those things. Okay, that's the kind of the introduction where we're going. Let's see how we got here. This is the main time series page for a particular site. We were fortunate enough to get some real public data from a location in New Zealand, and we have stage data here, which we can see here. Oh, that's the discharge. There we go. Here's the stage data. Here's the raw data. You can see that we have some problems a little bit, which we fixed using threshold corrections in the Aquarius time series server. And we see a whole bunch of field visits on the timeline here with the corresponding readings visible and available here in the main display. Now, one of the things I want to point out here, which will affect our rating curve, is the fact that we really don't have good readings for any higher flow conditions. As you see, all the readings are for medium flow, low flow, very little going on in the higher flows here. This is as high as we get, and that will definitely influence our rating curve. We have max and min for this range. The min is about 1 meter and the max 4.5 meters. That's pretty well true for the entire time series, which covers 10 years from 2012, more than 10 years actually, from 2012 all the way to 2024. The other thing we have is a big pile of field visit information. This was provided to us via a spreadsheet, which we then just simply loaded into the time series system. So this is a fairly bare bones field visit information, but we have the measurement date and we have the discharge and we have the stage, which is really what we want. We don't have any other information and we have a lot of it. So that's good. Between the stage data and the field visit data, we've got a lot to go on. So let's take a look at how we did that in the tool. So the rating review tool automatically knows about the field visits that we have in our system. I'm going to close some of these windows here for clarity. I do want to point out that, incidentally, any of these windows pops out into separate tabs. So if you've got multiple screens to do this with, or you want to zoom in on something, you can easily do that. So here are our field measurements. And in looking at these field measurements, what I found was that the measurements from early 2012 to early 2017 really fell along this line at the bottom. And then the measurements from early 2017 to mid 2020 were the top. And then there was some readings in the middle going forward from 2020 August until now. Now, I'm not an expert hydrologist. Again, this is all for the purposes of illustration of the kind of capabilities the tool has. But I thought, well, we can build 3 rating curves out of this. Speaking of experts, one thing you should know about this tool is this is the tool that's used by many leading organizations in the field, including the USGS, Hydro Environment Canada, and many others. This tool has been around for a long time. It's extremely powerful. It is used by real hydrologists, unlike me, the world over, and it has more than enough capabilities to create rating curves. So it is now entirely browser-based, which is fabulous. So now you have this nice browser-based tool that really you can use by to make really detailed and great rating curves. Okay, so that being said, we basically can just hit the timestamp here and we see where we're looking at. We're looking at rating curve 1, which is the earliest one. And here we have the things that we use. And then we can just draw the tool, and we'll show this shortly how to actually do this to make the rating curve. Now, one of the things that we have to do is to create the grades. I mentioned that we don't have any really high flow information, and you can really see that here. So the tool lets you create grades for the outputs. So here I've said anything below 1 QMEC, is not going to be very good. Anything above 14 QMECs is also not going to be anything we should rely on too heavily, but we have good ratings for the mid-range here, fair and good. And you can see that reflected in here, and you will see that reflected in the output rating curve. The other thing, as I mentioned before, are the rating periods. Just close the screen here, kind of stretch this out a little bit so you can see, and we can give it a start and end date for the rating curve. This is done so that the system will use the appropriate rating curve for the data from the appropriate time. So that's one rating curve. It's right there. Now I created a second rating curve for the higher data. You can take a look at that. There's that curve. And we're going to create the third one just so you can see how the tool works. We're going to create the third one here. And we're going to turn off the measurements that we're not using for this curve. There we go. And we see our data here. And we can now just draw a rating curve. Whoops, a little bit of mouse clumsiness. There we go. So we just draw a curve like that. Again, no expert eye, but we can take a look at the error stats here, and we can look at the calibration. Now you can see how this will work dynamically because I can just grab the curve and move things around, and you see the calibrations on the bottom are moving. So I'm going to try and center things a little bit better by drawing this curve. There we go. Now we've got our curve. It's not great. We're in a hurry. Now, I mentioned that the stage data goes from about 1 meter to 4.5 meters. Here, we're only at about the 2 meter level. So we can use the stretch capabilities of the tool to simply extend this curve. You can see the numbers moving. I went a little bit too far. No need to go that far. That's good enough. I'm just going to go up here. And that's it. We can now save this curve in all its ragged glory, and it's ready to be used. You might have noticed that we can play with offsets here. I can tweak offsets. I can add shifts. I can do other things. I did not add grades to this particular curve because I've shown this previously. And again, we're in a bit of a hurry to see what's going on. Okay, we can preview our curve right from the tool. So we can preview what's going to come out so that we can see the results of our work before we create a time series, which, however, I've already, in the interest of time, created in advance. There we are. But as you see here, there is a preview function, so we can kind of see what is going to happen before it happens. Then it's very easy, once you have that, to create a calculated discharge using the new derived time series. I've already done so here. Let's take a quick look at that. This type is rating model derived. The inputs are our new rating curve and the other input. So this is our function, and this is our independent variable x, as it were. This is the telemetry from the stage, and that's therefore our f of x. And now we can, like good high school algebra people, f of x equals y, the new time series, calculate discharge, parameters discharge, units are meters per second, and we're ready to go. And we can take a look at that. This is the actual output from that tool. We can go and scoot around to the place where we did have grades. So you can see all the grade markings at the bottom here. You can see that the field visits are at the bottom. As we said, we don't really have any high discharge functions, which means if we look at one of these, we can readily see that we think the grades are good here. This is suspect, this peak is suspect, and again, we're back to reliable information here. So the system takes care of all the grading for you. So that's one way of creating a rating, but the system is quite powerful and can do other things as well. We can add a rating curve from a file if we choose. So if we had a rating curve that had, or a relationship between two variables, and they don't have to be stage discharge. I've been recently working on curves that are doing turbidity and suspended solids, discharge and grade and area, grade, stage and area, reservoir area, stage and reservoir capacity and gigawatt output, etc. Any two empirically related variables can be associated with this tool and can be readily imported into a file. We can also create a new rating curve that includes calculations, standard equations, descriptive equations can be used. We can get quite complex spline curves using that. So there's certainly more than one way of creating a rating curve and more than one way of relating different variables that don't just have to be stage and discharge. I do want to show one really cool feature before I close this up, which is a really new feature in this tool and one that really, I think, is completely novel. This is also real data from Central America. This data was sent to us, and we're able to enter this data, and we have a nice profile information here, and we have the velocity information from the main discharge section. All this was entered into the system, and the system built this nice profile with the velocities and calculated the discharge quite successfully from that data. But we can do more than just that. We have a new feature in the tool where we can view this profile directly in the rating review tool. It immediately brings it in as a profile, and we can simply ask it to build us a theoretical rating curve just based on the profile. And it will mathematically calculate a rating curve. We can add breakpoints. We see here, perhaps we have got a breakpoint here so that we can move things around, and we can put in things like friction loss assumptions, velocity exponents, slope and roughness, and preview the curve, stopping. But we can do more than that. We can go to the rating curve tool directly from this profile, and it will directly build us the profile. It will import the profile, and we can simply click inside to have a rating curve, theoretical rating curve built, where we can add velocity exponents if we want. We can add calculated velocity and roughness if we want. We can add other segments if we want, as we might want to do here. And in general, preview the rating curve so we can immediately see the theoretical rating curve, which we can then adjust using field measurements or other ways of doing it. But the big time saving here is theoretical rating curve like this obviates the need for lots of historical data, such as field visit data or previous rating curves. You can get started fresh on a rating curve with just a profile and then move forward from there. So it's a huge time saver, really important breakthrough in the development of rating curves and to make it easy for you to work with the system. Well, that's it for the moment. Thank you very much. If you have any further questions or any questions, we of course love to hear from you. Feel free to get in touch with us, and thank you for your time and attention.